Hello, Brent Ritchie again. I'm going to work a few problems, applied problems, using the normal distribution. If you're following along on a review, it's number 18. IQ test scores are normally distributed with a mean of 100 and a standard deviation of 15. So a mean of 100, standard deviation 15. Find the X score that corresponds to a Z score of 2.33. So this one's a little different. Here is now in a standard, when you standardize your normal distribution, that's 0 and 2.33 standard deviations above the mean is that. And they want to know if this mean is 100, then what is the X value that corresponds with 2.33 standard deviations above the mean? Fortunately, we have the formula 0 equals X minus mu divided by sigma. In this case, we're given, I said Z equals that anyway. I'm not sure what I said. I might have said 0. 2.33 X minus 100 divided by 15. So we multiply both sides by 15, a little algebra here, 2.33 equals X minus 100. And 15 times 2.33, what's that, 35? Let me just check that. 15 times 2.33, 35? Well, 34.95. 34.95. That's X minus 100. So we add our 100 to both sides. And we find that the X value that corresponds with a Z value of 2.33 over here would be 134.95. So to answer the question, that would be the IQ score that is 2.33 standard deviations above the mean, 134.95. Let's try another one on the review number 19. The score on a mathematics exam has a mean of 76, a standard deviation of 8. Find the X value that corresponds to the Z score, 2.575. So they want to know what score corresponds to 2.575 standard deviations above the mean. So let's see, here is 0, which we know is mu equal to 76. And we want to come up here to 2.575. And we want to know what X value corresponds to that. We use our formula again, Z equals X minus mu divided by sigma, and we get 2.575 equals X minus 76 divided by 8. Let's multiply both sides by 8. And let me see what that is. 8 times 5, 8 times 2.575, 20.6. And then let me see, I got X minus 76 equals 20.6. Add 76 to both sides. X equals 96.6. So that is the test score that corresponds with 2.575 standard deviations above the mean. So this X value right here would be 96.6. One more. Assume the salaries of elementary school teachers in the United States are normally distributed with a mean of 34,000. This question's a little dated. Thankfully, they're higher than that. Hopefully in the state you're from. And a standard deviation of 5,000. What is the cutoff salaries for teachers in the bottom 10%? So this is a good example of using our chart backwards. Here's 34,000. They want to know the bottom 10%. What is the X value that corresponds to the bottom 10%? So we're looking for this area right here. The bottom 10%, let's see, as a decimal, is this. That would give us the bottom 10% right there. And we want to know what X value corresponds with an area of 0.10000. Well, we like to use this equation to find these X values, but the problem is we don't have our Z value yet. We're missing Z, we're missing X. So we can't solve it yet. We need to get one of those. Fortunately, we can find Z because we're given the area to the left of Z. There's the area to the left of Z. So this time we're going to look at our chart, but instead of looking down the left-hand column and across the top, we look out in the middle. And this is kind of what my chart looks like here. Here's the Z's. We look for the value inside the chart that's closest to 0.10000. I'm looking and I see here 0.1003, which is just a touch above 10%, and that happens to be the closest one. So that's in the middle of our chart where the areas are found. And this is on the negative, the chart with the negative values, because it is on the left of the mean. So these are the negative values over here. So once I find the area in the middle of the chart, I trace it back to the Z value here and here. And let me find that again. Negative 1.2 over here, up here, 0.08. So the Z that corresponds with the bottom 10% is negative 1.28. I'll come over here and work this. Now I think I can use my formula. Negative 1.28 equals X minus 34,000 divided by 5,000. Multiply both sides by 5,000. I get, this is multiplication over here, 5,000 times a negative 1.28, negative 6,400. Equals X minus 34,000. I add 34,000 to both sides. And I get X equal to 27,600. So if you are in the bottom 10% of elementary school teachers in pay, your pay is less than 27,600.